change to solve by completing the square. And I'm going to try to imagine picking the worst numbers possible. In other words, this will stretch you as hard as possible because it'll have as many fractions as possible. So if I had started with a 3x squared, and then I had minus 5x and minus 7. There we go. They're all prime numbers. And if we went through the steps of completing the square, we have a 3 out in front. And we always wanted to, remember I wrote it out, you want it to look like this. This was our first goal. We want just an x squared, and then we'll move the number to the other side. So do you see that I don't have an x squared, I have a 3. So I would have to divide everything by 3. And I hope you can see why this is somewhat problematic already, because does 5 divide nicely by 3? No, we would have to leave that as a fraction. I'm going to put my space already. I'm going to put my 7 on this side, but it also gets divided by 3, and then we have a space again. So we're solving by completing the square, but our numbers aren't nice. Which makes this a little bit harder. What would have to be here to get a 5/3? So that your outside and inside add together to get 5/3. Now the mental math is hard. But we've noticed a pattern all the way along. What was the pattern to go from this number to this number? Always half. Always divide by 2. Dividing by 2 is like multiplying by a half, which makes this negative 5/6. And if you multiply that out, what would go there? Well, that was just squaring that number. What's 5/6 times 5/6? Plus 25 over 36 and plus 25 over 36. How do you add fractions? You need a common denominator. So can you see that 7 over 3, I'll just write it off to the side, is the same as 84 over 36? And 84 over 36 plus 25 over 36? Is 109 over 36. The idea with math is that when you go to fractions, because you've been doing fractions since grade 7, you should be experts in fractions by now in grade 11. But it takes more time, right? This is harder mental math to do than the mental math if the numbers were nice. But you know your fraction rules. So, in my opinion, this is more annoying and more time consuming, but technically is not harder, because you should know your fraction rules. But because it's more annoying and more time consuming, I guess your chances of making a mistake increase, which I guess makes it a little bit harder that way. So now that you've got something squared, okay, and we're doing this right now with the hardest numbers possible because we need to go to the next level after this. We will choose something harder than the hardest numbers possible next. So, next I would square root both sides. If I square root this side, I'm going to get x minus 5 over 6. If I square root this side, I have plus or minus the square root of 109. This is actually kind of nice that 36 square roots nicely to 6. I could have picked a number that wasn't as nice, so that I'm not too sad about. And then finally, we would have to add the 5 over 6 to both sides. And we already have a common denominator, so that's also nice. Oh, my 100 and, wait a second, did my number just, no, this was right. 84 and 25, 109. Good. 109, mental math, does not divide by any perfect square, so it can't be simplified. This is our final answer. We need to be able to, you will get questions with fractions. We need to be able to do it with fractions as well. And I said this was leading us up to the next level. So what I'm going to do for the next level is right beside this, I'm going to actually maybe shrink this down a little bit for us. That didn't work. View, zoom, whole page. I'm going to take what we did here, highlight all of that, and group it together, shrink it down just a little bit. So this was the idea with what I said were some of the hardest numbers possible because we got a whole bunch of fractions and had to do, like, we really had to use the strategy of dividing by 2 and squaring because the numbers weren't things that were easy to do in our head mentally. What would be harder to do than the hardest numbers? What are we doing next? So right beside this, I'm going to solve this same thing, but instead of the hardest numbers, I'm just going to use letters all the way through. So instead of the number 3, I'm going to use the letter A. Instead of the number -5, I'm going to use the letter B. And instead of the number 7, I'm going to use the number C, or the letter C. What we're doing right now is what mathematicians do to make formulas. And we're going to develop a very famous formula called the quadratic formula. The quadratic formula says maybe there's a formula that you could just, if you get this, you could just plug numbers in and get the answer right away. Ooh, that kind of sounds exciting. If I could get the answer right away without having to do all this completing the square work, especially when I have fractions, that might be really nice. Well, in order to create the formula, we start off with a statement that says A, B, and C can be any numbers we want. Could you still follow the steps if you had letters? So we look at the numbers, and this is why I'm doing them side by side. What did we do first when we had the 3 out in front? Do you see you divided everything by 3? So if you have an A out in front, what should you divide everything by? Divide everything by A. So if I divided everything by A, I would get x squared plus B divided by AX. And then I left a space. I moved the C over to the other side, which would make it -C. It gets divided by A, and then I would have a space again. That was our first step. We divided everything by 3, and we got it into this form. Next, we wrote something something squared. Well, how did I go from here to here? I divided by 2. So if I have b over a, dividing by 2 is the same as multiplying by half. You see that that would be b over 2a. And then how do we go back to that space? Whatever number's here gets squared. It's the last term. So if I square b over 2a, I get b squared over 4a squared. And if I add b squared over 4a squared, I want to do that in blue. Sorry, I'm going to switch it. There it is. It's in blue. Then I would add b squared over 4a squared there. And then I combine things to get a common denominator to add my fractions. Do you see that I would need to multiply, to get a common denominator of 4a squared, this would need to be multiplied by 4a on top and bottom to get 4a squared? So then I would have a common denominator of 4a squared. And on the top, I would add my b squared and my negative 4ac. So normally, if I was writing it this way, I'd probably write negative 4ac plus b squared and keep the order. But to match it up with the formula, they write the b squared first and the minus 4ac afterwards. Okay? Whew. We did the same steps with letters. So if you know your mathematics with numbers, you can do the same steps with general variables, saying they could be any number there. What did we do next in the completing the square? We square rooted both sides to get rid of the square. If I square root both sides, I'm going to get a plus or minus. The square root of the top is b squared minus 4ac. And if I square root the bottom, it actually works out really nice. The square root of 4 is 2. The square root of a squared is a. And then finally, well, not quite finally, but we can move the b over 2a to the other side. And then we notice they already have a common denominator. And this is the famous quadratic formula. Probably one of the most famous formulas you learn in high school. And the way that you get the quadratic formula is the same way that you do completing the square with numbers. So what I did here, review the whole thing. It's really small now, but what I did first is I picked what I thought were the worst numbers possible, so things didn't work out nicely at any point. No nice simplifications, no nice fractions, overall not nice. And I worked through it and I got my final answer. Then right beside I said, okay, could I do all of those same steps if I used letters representing any numbers? And now what we're going to do is back to the page width. I'm going to go back to this first question, 3x squared minus 5x minus 7. Do it in purple. Here's our original question. Now, using the formula, this is A, this is B, this is C. So since we have a formula, we could say the answer is going to be x equals negative b, so negative negative 5, plus or minus the square root of b squared, negative 5 times negative 5 is plus 25, minus 4 times a was 3, times b was minus 7, all divided by 2 times a. And watch what happens. Negative negative 5 is plus 5. Plus or minus 25 plus 21, 84. 25 plus 84 is 109, all divided by 6. Check that out. Is that not the same answer? Look at that. How fast was that compared to completing the square? Is that not faster using the formula? It's beautiful. The formula's in some ways too good. I'm a little bit sad. Because the formula is so good, students stop using completing the square. Totally makes sense. Doesn't it make sense to plug things in? Isn't that a lot faster than completing the square? It almost always is. There's a couple of situations where it's not. But it almost is always faster. It's on your formula sheet. So the sad part is students stop completing the square and then lose the ability to make the formula. So I would highly recommend you maintain the skill of how to complete the square. Because then you can develop the formula, and then that formula is completely yours to use. Yes?
If a question on like a quiz or test asks solve by completing the square,
You still have, you can't use the formula.
okay.
So your quiz on Thursday only goes up to 3.3, no formula allowed. Oh, so you're gonna know this new formula, but you will not be allowed to use it on that quiz. So let's go to example 1. Well, they have the proof of it as well and explain it, but I find doing it side by side with a question you did with numbers is a really nice way for you to remember what you did. Because what makes sense in numbers isn't necessarily intuitive with letters. Like this, especially this part here, where we divided by 2 and squared, the green and the blue dotted part here is a little bit harder with just letters. So let's go to example 1. So now when a question says solve, you have 3 options. You can factor and use the zero product property. You can complete the square, or you could use the quadratic formula. And they also all have advantages and disadvantages. Factoring is the fastest if you can factor. But sometimes you can't factor. Quadratic formula is generally quicker than completing a square, unless the middle numbers are nice. So I actually feel like this is if I would analyze these ones and say what I think is the best based on these, I notice I can't factor, but I would actually say completing the square is the best method for this one. And I'll show you why, but we'll use the formula first. So we now have developed the quadratic formula. It's on your formula sheet. It looks like this. When you have a chance, memorize it, because you need it memorized for AP Calculus. So for A, there we go. For A, if I was using the formula, I would say my A value is 1, my B value is 2, so I go negative 2 plus or minus square root of B squared, 2 squared is 4, minus 4 times A is 1, B is 7. Oh, actually this one is really good with the quadratic formula. Over 2 times 1. So we plug everything into the formula. And then we simplify And here I get 4 minus 28 would be negative 24 over 2. What's the square root of negative 24? That should bother you just a little bit, maybe a lot. Can you square root negatives? Should become your favorite thing in the world. If you get a square root of a negative in the quadratic formula, right away you can go not possible and say there is no solution. That's crazy. You're done. We're just like, you don't have to do any more work. As soon as you get a negative inside your square root, that's impossible. There's no solution to this one. There are no answers. The bottom of the page, it says no real roots, because technically there's a branch of math that uses imaginary numbers that would let you solve this. Doesn't that sound weird? Imaginary numbers? There's really only one really important imaginary number. Does anybody know what it is?
Infinity?
No. The number I. The number I is equal to the square root of negative 1, which is not possible in real numbers. But if you use your imagination and use imaginary numbers, it is possible. But we don't have to do imaginary numbers in grade 11. They took it out. They used to add it. Okay, so actually, I would say for the first one, quadratic formula is actually the best. For the second one, again, we plug in numbers. Now b is negative 2, so negative b would be positive 2 plus or minus. B squared is still 4, minus 4a, and this time c is negative 7. So if I simplify to plus or minus, this becomes 4 plus 28, which is 32 over 2. And this is the right answer, but you would lose marks because it's not simplified. We have to put this simplified in lowest terms. So, what does that mean? It means I have to look at 32. You recognize 32 as 16 times 2, which makes it 4 root 2 over 2. This is also the right answer, and it is more simplified than the previous right answer, but it would still cause you to lose a half a mark because you haven't simplified completely. Because when you have a fraction with one number on the bottom, like this 2 is on the bottom, you have to check, is there something that divides all 3 of those terms? You can divide everything by 2. So if I divide everything by 2, I would get 1 plus or minus 2 root 2, and this would give you full marks as a final answer. So because of that, I will say that sometimes the quadratic formula is not better than completing the square. Because we started off with x squared minus 2x, and if I leave a space and put the 7 on the other side and leave a space, it's not hard to see this is x squared minus 1, which would mean I'd have a plus 1 here and a plus 1 there, which would give me 8. I square root both sides. Remember the plus or minus. And when I move the 1 over and I simplify this, the completing the square often, if the answer could be simplified, the completing the square gets you to the simplified answer more quickly. The quadratic formula gets you to a right answer more quickly. So like, this is the right answer, but it's not simplified. And it took some work, more work to simplify. Whereas completing the square gave us the right answer. It still wasn't simplified. We had to simplify the square root of 8, but the simplification was easier. So sometimes completing the square is still better. Okay. Questions for practice? Circle 4, 5, and 6.